Welcome back students to our maths class of class 7, and this is question number 11 of exercise 5.1. I will explain you this sum and you will get the answer written in the written notes. Okay, what the question says, in the following figure, this is the figure, is angle 1 adjacent to angle 2, and we have to give reasons. Now first of all, we again have to recall the definition of what is meant by adjacent angle. Three conditions are to be satisfied for adjacent angles. The first condition is that they should have a common vertex. Second condition is that they should have a common arm. And the third condition is that their interiors should be different. Okay, let us check one by one. This is angle 1. The interior of angle 1 is here and interior of angle 2 is here. So their interiors are different. They are not interacting with each other. There is no intersection between the interiors of angle 1 and angle 2. So one condition is satisfied. They should have a common arm. Here we have a common arm for angle 1 and angle 2. Therefore, second condition is also satisfied, that they should have a common arm. But the first condition, the third condition is satisfied. Interiors are different. Common arm, the second condition is satisfied. But the first condition, they should have a common vertex. Vertex of angle 2 is here and vertex of angle 1 is here. So both the vertex are different. The first condition is not satisfied, that is, they don't have a common vertex. Therefore we say that angle 1 and angle 2 are not adjacent to each other. So our answer is that no, angle 1 and angle 2 are not adjacent to each other. Why? Though they have a common interior, a common arm, but their vertex are different. So this is the explanation. You will get the written thing in the notes. So we move towards question number 12. Okay, what is question number 12? Two sums are there. Second sum, I will explain you. Second sum. Okay, let us draw the figure. Here is 25 degree, okay. Here is 40 degree. Here is angle X. Here is angle Y, and here is angle Z. So whatever definitions we have learnt up till now, depending on those definitions, we have to find out the given angles X, Y, and Z. The same thing is to be done in first sum also, but the first sum is quite easy, so we can solve it, or you can just look at the sum and you can say, you can find out how the sum has been solved, so that will come in the written notes. So let us solve the second sum. Now, first of all, we have to find angle X, angle Y, and angle Z. Okay, so here we can see, if you, just a moment. If you don't consider this part, okay, if this part is not considered, then only this much part, here you can see a straight line is there and three angles are there, 40, X and 25. Okay, so these three angles are forming a straight line angle, and the measure of a straight line angle is 180 degree. So we write that given angles 40 degree, 25 degree and X form a linear pair. Okay, why linear pair? Because they are adjacent also, they have a common vertex, common arm, and they are straight line angles. So all the all the addition of these three angles will be 180 degree. Therefore, X plus 40 plus 25 equals to 180 degree. Okay, X plus 40 plus 25 equals to 180 degree. Now X plus, only we have to solve 40 plus 25. 65 equals to 180 degree. X equals to 180 minus 65. I hope you are getting why we have subtracted it, because this is a simple equation. 65 is transposed to RHS, so plus will become minus. Therefore, X equals to, out of 180, 65 is gone, out of 10, 5 is gone, so 5. And out of 17, 6 is gone, so 115 degree. So the value of X comes to 115 degree. Now, here you can see this is a straight line, this is a straight line, they are intersecting each other. Angle Z or angle 40 degree and angle Z, they are forming a pair of vertically opposite angles. So, this is the first. The second, X is found, X equals to how much degrees? 115 degree. Now, the given angle 40 degree and X are vertically opposite angles. Z and 40, they are vertically opposite angles. Therefore, angle Z equals to 40 degree. So X is found, Z is found. Now 40 and Y is known, Z and Y is known, Z is known. So Z and Y can be found. If you forget this top part, Z and Y, they are forming a linear pair, straight line angles again. Angle Z and angle Y form linear pair. Therefore, angle Z plus angle Y equals to 180 degree. What is the value of angle Z? 40 degree. So 40 plus Y equals to 180. Y equals to 180 minus 40. Therefore, Y equals to 140 degree. So done. The value of X is found, 115 degree. The value of Y is found, 140 degree. And the value of Z is found, 40 degree. And we have found all the given unknown angles. With the help of whatever definitions, those 5 related angles we have learned, with the help of that, we have tried to find out all these things. Okay, so question number 12, question number 13 are just fill in the blanks. I will send you the photograph of the fill in the blanks. And question number 14 also I will send you in the notes. That is also very easy. Only you have to observe the figure and you have to name the angles, you have to name the pairs. Okay, so exercise 5.1 ends here. Okay, before moving to exercise 5.2, another type of angles that we have to see. Those angles are angles formed by two parallel lines and a transversal. What is meant by this? So, two parallel lines. What is meant by parallel lines? Parallel lines are those lines which do not meet each other. They are parallel to each other. If you go on drawing the lines continuously, they will never meet each other. So these are called as parallel lines in 6th standard. You are very well known with the parallel lines. And what is meant by a transversal? When two parallel lines are there, if another line cuts this two parallel lines, now this line, suppose we say this is the line L. It is cutting first parallel line here. Say this is the line A, this is the line B. So line L is cutting A here and B at this point. So you can see at this point 1, 2, 3, 4, 5, 6, 7, 8. Total 8 angles have been formed and we have to name them and we have to see what type of angles these are. Once you get this concept, the whole of exercise 5.2 is the easiest exercise. Only you have to know the concept. How many types of angles are there here? Interior angles, exterior angles, whatever angles are there, that if you see, you can easily find out, or you can easily solve exercise 6.2. Okay, before going here, first we will name the angles. Let this be angle A, let this be angle B, let this be angle C, and let this be angle D. In the same way, here would be E, F, G, H. A, B, C, D, E, F, G, H. Okay, you can name them anyway, no problem. Naming is not a problem, but to find out the angles is very much important. Now you can see here that A and B are two parallel lines. So between these two parallel lines, four angles are there: D, C, E and F, or C, D, E and F. And outside these two parallel lines, again four angles are there: A, B, H and G. The angles which are between these two parallel lines, they are called as interior angles. They are called as interior angles. The angles which are on the outside of the parallel lines, they are called as exterior angles. Okay, so these are the first two types of angles that we are going to see. Now here, types of angles. Plus properties also we have to see. The first type of angle, interior angles. Okay, interior angles. Angle C, angle D, angle E, angle F. Angle C, angle D, angle E and angle F. Second type of angles, exterior angles. Understood why these are interior angles? Because these are between the two parallel lines and these angles are outside the parallel lines. Exterior angles, angle A, angle B, angle H and angle G. So interior angles we have seen, exterior angles we have seen. Now next types of angles. Two types of angles we have seen. Let me draw this a smaller figure. Okay, so I will draw here a smaller figure. A, B, C, D, E, F, G, H. So this L is called as transversal. These are two parallel lines. These are the angles. Interior angles we have seen, exterior angles we have seen. Now third type of angles, corresponding angles. Corresponding angles means above this parallel line, these are the two types of angles. Above this parallel line, these are the two type of parallel angles. Means on above, two angles are formed. On this line, on above side, two angles are formed. This is to the left hand side of transversal. This is to the right hand side of the transversal. So A and E, they are corresponding angles. Angle A and angle E. In the same way, angle B and angle F. Angle B and angle F. In the same way, below the line, here D is there, below the line H is there. So angle D and angle H. Here angle C and angle G. Angle C and angle G. So these are the corresponding angles, and there is one interesting property about these angles. They are equal in measures. They are equal in measures. That means Whatever is angle A will be same angle E. Whatever is angle B will be same angle F. D and H will be equal. C and G will be equal. A and E will be equal. B and F will be equal. D and H will be equal. C and G will be equal. So these are called as corresponding angles. Third type of angles. Now the fourth type of angles. Fourth type of angles. Alternate interior angles. Angles are interior, that means BCEF, but they are alternate. Alternate means one angle is on the left hand side, another angle is on right hand side. So here you can see D and F. Here if you see, you can see a Z is formed, a Z like structure. So the angles of Z, D and F. So these are alternate interior angles, angle D and angle F. This is one of the pair. Again here angle C and angle E. Angle C and angle E. Again, now they also have an interesting property. Okay. Again, these alternate interior angles, they are equal in measure. They are equal in measure. That means D will be equal to F, C will be equal to E. Okay? Alternate interior angles. Next type of angles. Fifth, alternate exterior angles. Alternate exterior angles. A and G, B and H. Angle A and angle G, angle B and angle H. No properties there for these angles, only the properties for alternate interior angles. Six type of angle. Okay. This is the last. Interior angles on same side of transversal. Interior angles on same side of transversal. What does this means? This is the transversal, this is the left hand side, this is the right hand side. Interior angles means DCEF, but the same side of transversal, that is on the right hand side, that is on the left hand side or right hand side. On the left hand side there are two angles, angle D and angle E. Angle D and angle E. And on the right hand side, angle C and angle F. A very interesting property is there about these, that they are supplementary. They are supplementary. That is, angle D plus angle E equals to 180 degree and angle C plus angle F equals to 180 degree. That means addition of these two angles will be 180 degree, addition of these two angles will be 180 degree. When these conditions are there, when we have two parallel lines. Okay, so two parallel lines and a transversal. And if these are the conditions, that interior angles on the same side of the transversal are supplementary, alternate interior angles are equal in measure, corresponding angles are equal in measure, then we say that these means when the lines are parallel, these will be the conditions, and when these conditions exist, these two lines will also be parallel. Okay, so these are the angles formed by two parallel lines. We stop here. Thank you.